Welcome to my YouTube channel, Tushari Smith Academy. Today I'm going to do the grade 11 second term English medium equiangular triangles. That is the 14th chapter. Before we learn the equiangular triangles, there is a special theorem, right? First we learn that theorem. It says, now there is a triangle. I'll just take this triangle and I'm drawing a parallel line to one side. I'll take these two lines are parallel. This line divides the other two sides proportionally. If this is A and this is B, this is C and this is D. Centimeters, 3 centimeters, D centimeters, like that. Right? By this line, the other two lines divides proportionally. Proportionally means the ratios are same. A is to B equals C is to D. Right? That means A over B. Ratio I can write as a fraction. C over D. That is the result we get from this theorem. Now read this theorem. A straight line drawn parallel to a side of a triangle divides the other two sides proportionally. Right? Look at this example. This side is 3 centimeters x and 5 centimeters, and these two are parallel. Then according to theorem, we know these two are proportional each other. 3 over x equals 5 over 20. Then we can find the x value. Then you can do the cross multiplication. That is 60 equals 5x. Then x equals 60 divided by 5. That is 12 centimeters. This theorem is a very small theorem, but very useful when we want to find the lengths. Every theorem has the opposite of the theorem. We have to learn the opposite of the theorem. That is called converse of the theorem. Then this theorem also has a converse of the theorem. It says, if now there is a triangle. If a straight line divides the two sides proportionally. Now I draw just a straight line. Right? I just draw straight line. These two sides are divided proportionally. That means A over B and CD. When we get the ratio A over B equals C over D. In that manner, if I draw a straight line, that line is parallel to the third side. Earlier, we drew the parallel line. These are divided proportionally. Now, we draw a line proportionally. The line is parallel. That's called converse of the theorem. Almost same theorem. We are telling in the other way around. Right. Now only we are learning the equiangular triangles. Right? Even though name is there, we learned a new theorem after that, equiangular triangles. What do you mean by equiangular triangles? Now you have done, can you remember, congruent triangles? What's the difference between congruent triangles and equiangular triangles? Most of the children, they think congruent triangles and equiangular triangles are same. Actually, that is not. Congruent triangles means like identical twins, right? That have you seen identical twins? The features are same, nose is the same with the other person, right? Everything, size also same. Likewise, congruent triangles, if the two triangles are congruent, the areas are equal, right? All the features are same, and the sides are equal, angles are equal if the two angles are congruent, and the areas also equal. But equiangular triangles are not like that. It's like smaller brother and the younger brother. I Malli. The smaller brother and this is the elder brother. Not the younger brother, elder brother. Elder brother and the younger brother. Their features are same. In the same feminine, have you seen? Aya and Maya are same with the same features, right? But the sizes are different. Now look at this here. These two triangles, this equals this. Angles are equiangular. By name also we can understand the angles are equal. If I say to draw to X person, this one child can draw 5 centimeters, 6 centimeters, and 7 centimeters. Another child can take 10 centimeters, 12 centimeters, and 14 centimeters. Right? But the features are same. So, these type of triangles are called equiangular triangles. They are not equal in area. Right? They are not like congruent triangles. Right? And in equiangular triangle, there is a special feature. What is that special feature? The corresponding sides are proportional. Right? Now look at this. I'll make it a little bit bigger. That is a special feature. Right? Now look at this. This one line angle. I'll take AB. AB. AB is AB and the corresponding side is PR. The ratio PR equals BC. BC equals QR. It's not equal QR. When you divide AB over PR, then ratios are proportional. Sides are proportional. The ratio of these two is equal to the ratio of BC over QR. Then AC over PR. The ratios are proportional. That's a special feature, right? Of equiangular triangles. Now we'll go further. Right. Now we'll see how to identify the equiangular triangle. Can you remember congruent triangles? In congruent triangles, we had 4 cases. SSS, SAS, AS, RHS. Here also, there are 3 methods to identify the congruent triangle, equiangular triangles. 3 methods, right? Now, obvious the first method using angles. Very easy. If the 3 angles are equal to the to another triangle, the two triangle, if there are 2 triangles and if the angles are equal, you can say these are equiangular triangles. First method is very easy. The first case. Second one, sometimes you are given 2 triangles, right? Just a minute. 2 triangles, sides, lengths, and included angle. Always included angle should be there. Included angle. Included angle and 2 sides. Look at this. Right? Actually, this diagram, it says equal. That's wrong. Huh? I'll just, different lengths should be there. We'll say 5 centimeters and this is 3 centimeters. Right? And this is, we'll say 6 centimeters. Right? Now, included angle is, 2 included angles are equal. That should be equal. Right? Now, you have to take the the corresponding sides are proportional. That means now we don't know with what we are taking. Right? So, when you have the lengths like this, I'll put the number. Smallest one, I number them. This is number 1, this is number 2. What's the smallest one? This is number 1, this is number 2. Then you take corresponding side. 1. I'll take 1 and see 3 over 6, the corresponding ratio. Then you get 1 over 2. Then second one, 5 over 10. They are 1 over 2. Right? The sides, then corresponding sides are proportional. right? Corresponding sides are proportional and the included angles are equal. These two are same. So we can say these two triangles are equiangular triangles. The next one, that is the second method, how to identify the right. Sometimes they give only the sides, no, not even an angle. Look at this. Only the sides. Then when you are given the size, you number them. Like earlier, the 3 centimeters, I think you can see that. 3 centimeters is 5. The second one, right? Lengthwise, I number them according to ascending order. This is 4.1 number 1, this is number 2, and this is number 3. We'll take numbers now. Okay, now I'll take the number 1. 1, 4.5 divided by 3. That is 1.5. Second one, 7.5 divided. We have to see all the ratios are proportion. 7.5 divided by 5. That is 1.5. Third one, 10.5 divided by 7. They are 1. All the sides are proportional, same. Then we can say the two triangles are equiangular triangles. Right. Now, those are the 3 ways of finding, checking the equiangular triangles. I hope you can understand this lesson very well and subscribe my YouTube channel and click the bell icon also. Then when I upload the new lessons, you can get it. Thank you for watching my video.